be easier than arithmetic sequences, mostly because you've seen the arithmetic sequences already. And I'll try to do a little bit better of a job with the recursive form of the sequence. So, make sure okay. All right. So, two different formulas again, a recursive and an explicit for a geometric sequence. Now, a geometric sequence is a little different. Instead of having a common difference, it has what's called a common ratio. So, common ratio. Now, normally when we think of with ratios, we think of fractions. It's not necessarily a fraction. It is a number. So let's start with an example. I'm going to start with 5, 10, 20, 30. No, not 5, 10, 20, 30. Sorry, 5, 10, 20, 40. Okay. Now, common ratio basically says what number do I have to multiply by to get to each one. You'll notice that this one went up by 5, this one went up by 10, this one went up by 20, okay? It's growing exponentially. So you're looking at what number do I multiply by, not what number do I add by. So if we multiply each term by 2, we get the next term. So then the next sequence would be considered, we multiply by 2 would be 8. So the common ratio is what we're going to use instead of a common difference because we are going up by multiplying. So geometric sequences, the terms are multiplied by a common number. With arithmetic sequences, they're added to a common number. So I hope we have a better understanding, since yesterday we talked about the recursive functions, of when I give you this recursive function, what it means. So the recursive version of a geometric sequence looks like this. Okay? We're going to have first of all, whatever term we're looking for, the n is the term number, the un is the entire term, equals my common ratio times un minus 1. So these are subscripts, the n and the n minus 1. So basically, if I were looking for, just an example, if I were looking for the 50th term, it would be 50, it would be u50 equals r times u49. Now, with the recursive form, we also need to establish what is the first term. So once we know those two, we can use the recursive form to find whatever term we need to, as long as we are going consecutively. Again, I would not use that formula other than just to know the formula. So let's talk about the explicit. The explicit is un. I'm going to drag on my board today, I apologize. Okay, the explicit is un equals u1, so whatever the first term is, times the common ratio to the exponent x, or n minus 1. So, if I were looking, again, for the 50th term, u50 is going to equal u1 times the ratio raised to the power of 49. Okay. Now, something else I want to talk about with the common ratio, there's another way to find it. You could look at the patterns and see what are we multiplying by to get to the next number. But the other way to do it, the common ratio, is to say that r equals un plus 1. Okay, so whatever term is after the one we want, divided by un, is going to equal r. So, alright, now, for examples. I'm only going to do one example because these are fairly simple problems. So if I have this sequence here, 2, 10, 50, and 250. Now if you just look at that, you're saying, okay, what am I multiplying by to get to each one? It is 5. But to find it using the formula, I want to show you this, okay? So r equals, if I were to take 10, okay, which is u2, all right, this is u1, and divide it by 2, I would end up with 5, okay? Now that will work with any of them. If I do 50 divided by 10, 250 divided by 50, that's how I can get my common ratio. So I get my common ratio, and now I can write my explicit formula. Explicit, which is UN equals U1 in this case, which is 2, times my ratio, 5, to the n minus 1. Now the recursive is UN equals 5 times U n minus 1. Okay, and these n's and n minus 1 are subscripts, where U1 is 2. Okay, that's my recursive function. Now I'd love to find the 10th term. So let's go. We're going to find the 10th term. Okay. So I'm going to use the explicit function. I would not use the recursive function to find this. If I did, I would have to go through 6, we have 4 terms. We have to go 5, 6, 7, 8, 9, 10. So I'm going to use the 10th term, and I'm going to use the explicit function. So U10 is going to equal 2 times 5 to the 9th, because it's n minus 1. If n is 10, 9 is n minus 1. And I throw that in a calculator, and I get it equal to 3,906,250. It's basically what your homework's going to ask for. It's going to ask for common ratio. It's going to ask for an explicit function, recursive function, and it's going to ask you to find a term. Some of them, they're going to be between 8 and 10. So